Hello everyone, today we are going to work on how to work with multiple enemies. So as you can see here, we have three enemies and they are kind of coming at me from different directions rather than coming from the same directions all at once. So here is the preview. So of course we need further improvements to the system, but compared to what we had before, we will now implement a system that which allows enemies to place them around the player rather than coming directly towards the player. So here is the demonstration again. Okay, before we get started, I'd like to remind you, you can download the project files of this project and all other thousands of projects that I have worked on from the Patreon page. Once you become a member, you can download anything without a limit, so feel free to check it out. I'll leave the link in description below. And this is a part of this action RPG with game playability system series I'm working on, so you can watch all other episodes as well in my channel. I'll leave the link to the full tutorial series in the description. Let's get back to today's tutorial. Okay, so right now if I have multiple enemies, let me put two of them like this and then start the game. This is what would happen. They would overlap everywhere. See, they are kind of running into each other and it's really hard to follow what's going on because they are trying to attack me all the same time. So what I want to do is I want to distribute them around the player in a manner that they don't stumble upon each other. So for that, let me first go to the AI and AI controller behavior tree. Here I have this move to. This is the node which moves the AI character to the target, to its target. So here let's add a new behavior, new blueprint task, behavior tree task. I'll call it BT task flank. So the reason I name it as flank is because instead of directly moving the player, moving the character towards the target, I want to make it go around the player, around the target and reach from different directions. Okay, now here let's override receive execute AI, and from the control pawn we can get vector location, and also I'll add a new variable target actor from the type of blackboard key selector. So here I will assign the target actor object to this key. Then we can get value as actor, so we can access the actor, and then we can get actor location. Okay, now we got two locations. Now here what I want to do is imagine a situation like this. Here now in a case like this, let me take a screenshot and explain. Now here a direct line like this, let me use red, So by considering the direction from the target to the enemy, or to the AI character, we will have a line like this, and in around this line I will draw another line like this, and then I want to get few points like this, maybe this, like that. Okay, and I want to direct these each different characters to these different points like this. So this will change as the player character moves around, and also I will get these positions randomly, so there will be randomizations here and there. So whatever, this will allow us to distribute these enemy characters around the player, and also this position will also change a little bit, like maybe randomized. Okay, so that's the basic idea I am going with. All right, now how do we implement this? So here first we can get a unique direction vector from the player, from the target to the character, a character, and then if I multiply this by a random value, random float, we need to first convert this to a float. In range, maybe something in between 600 and 300. Okay, now this will, and if I add the target location, target character's location to this will give us some point along this line in the distance between 600 and 300. And also from this character actor, I'll get right vector, and then I'll multiply this with another float, let's say, so this is to get these points. So if I assume the distance between these 2 points are like maybe 150 units, or we can do something like this. Here multiply 150, and I need on both sides, points on both sides. So here let's get random int in range, random int in range. The reason to use integers is because we can have whole values, 3 plus 3 to minus 3. Okay, and if I add this also, now we will get points like this. Alright, and then I'll call AI move to on this controlled pawn as the acceptance radius. I'll use 100. This doesn't, we don't have to move to the exact location. And here finish execute. Maybe even if it fails, it's fine, because this is just a flanking. So even if we can't go to this this exact destination, it's fine. we can continue to the next step. So now here, before this move to, I'll call that flank, pt task flank, and here I'll select as the target actor. So now let's see what happens. Okay, they saw me, and yeah, they are going to different places, but the issue is they turns away from me, and when they turns away from me, they stop seeing me. And what's this error? Okay, here. All right. We may have to do is valid check. And if it is not valid, we can finish execute with a false. Alright, now to address the turning away from the target issue, so the turning keep looking at the target is implemented in this soft lock system that I have, but I have implemented this ability thinking about the player. So this ability is activated when I equip the sword here. When this equip sword ability is activated, here I activate soft lock ability also, which keeps the character turns towards the whoever the enemy. But here the issue is I get the enemy through this function, and here I have a distance. I only consider enemies within 250 radius from the character. So this will not work for AI characters, because as you can see here, we place them in distances beyond that. So we might need a different approach for the AI characters, or perhaps we can do something like this. Here, let me get some space. We can get covered actor from actor info and get is player. So this is a function that we have already implemented through this PPI character in our character class, which returns true if it is controlled by a player, otherwise it returns false. So here, if this is true, then of course we can take this path, otherwise we can here. Otherwise, for AI characters, we might need to consider using whatever the target actor the AI character has identified through the perception system. So for that, here, let me open AI NPC blueprint. So this is where we set the target actor, and what we do is we just set the blackboard value, and then the rest is handled in here in the blackboard, in the behavior tree. So let me open my player character blueprint. here. Oh wait, what did I do? Right. Oh, sorry. Let me get the event graph here. In our character blueprint, we have a function. We have this lock target variable, and I set it here through this lock on enemy function. So if I call this from the behavior tree, and also if I implement a way to access this from the gameplay ability system, from the gameplay ability also, we can use this as you use this instead of getting this closest enemy for AI characters. Okay, so how do we do that? So this lock on enemy is implemented through the BPI character interface. So let me open that and get locked enemy. Let's put it down to the character, and it should return an actor reference. Locked enemy. Right, and here now the character get locked enemy, I'll simply return lock target. All right, now we need to call this also. For that, I'll add another behavior tree task. I'll call it BT task. Lock on target and override receive execute AI. On the control pawn, I'll call lock on enemy and finish execute. So as the lock target, same as before, I will have to define a blackboard key selector. Where did I? Yeah, like this. Same thing. And pass it as the lock target. Now we can here, before we equip, I'll call lock on target and select target actor. Okay, now let's see. They are not doing anything. Why? Oh, here I didn't mark it as true. Okay, now it should work. Yeah, see, now they are coming to different positions. And why are they not attacking? Maybe I forgot to mark as true in here also. Yeah, exactly. So that's why they are not attacking. Okay, let's see. They're coming. Okay, see, now they are going around before attacking me. Okay, nice. So it was better than before, and of course we need to do more improvements, but this is a improvement from what we already had. All right, so I think we can stop this episode right here. In upcoming episodes also, let's continue to improve the system, and as always, updated project files will be available for the download in Patreon page. Link could be in the description below, and feel free to let me know what else you guys think about the system I'm working on. Your thoughts, comments, critics, everything, let me know in the comments below, and see you in the next episode. Goodbye.